sketch for graph, like, and how is the basic graph for polynomials, quadratic, linear, cubic, and so on. Now we're going to have a look at terminologies that concern about shape of graphs, and we're going to have a look as well on average rate of change of a function. So that will be for topic 2.3. Okay, so let's start with terminology, some terms that you're going to come across for graph of functions. So the first terms that we're going to come across is called as the turning point. So what is a turning point? So turning point is basically a point at which graph changes from increasing to decreasing, or the other way around, or decreasing to increasing. For example, so let's say that my graph is going down. Okay, so this is actually going down, and when I arrive at certain point, for example, the x point over here, so my graph starts increasing instead. So this is this x point over here, so it is known as the turning point. Or it could also be the other way around. For example, let's suppose that my graph is actually going up, it's actually increasing, and I reach at a certain point, so which is going to be this point right here, and then after that it starts going down, so that is going to be known as this point right here. So that is actually this point right here, turning point. Okay, so turning point, it could either be a maximum point, or it could also be a minimum point, and it's known as local maxima, relative maxima, or local minima and relative minima. Okay, so what is the difference between maxima and maximum? So maximum is singular, one point. So maxima means multiple points, more than, it's the plural of maximum. Okay, so maximum and minimum, so it is also known as absolute minimum or global maximum, or absolute minimum or global minimum. So it's called as maximum, not maxima. So from here we can tell right away that there is could only be 1 point. So it's going to be only 1 point, and the same goes for maximum, minimum. So minimum as well. So there could be only one global minimum in the function itself, so only 1 point. Okay, so what happened is that, what is a maximum point? So maximum point is going to be the largest value reached by the function. It's going to be 1 point that is the largest, while the minimum is going to be 1 point, so that is the smallest. So that is maximum and minimum, and the other name for them, so they are also known as absolute maximum or global minimum, and absolute minimum or global minimum. So it's going to be the highest or the lowest point in the function itself. Okay, relative maxima or relative minimum, when it comes to being maxima, so it's going to be the highest point in a particular section. For this case, we use the term maxima because it's going to be, could be more than 1 point. Okay, and the same goes for local minima. So instead of minimum, using the term minima, because local minimum could also be more than 1 point. Okay, and then the last term will be zeros. So what are zeros? So zeros are going to be the value of x when you set f of x equal 0. So basically, so this is, if you remember, this is going to be when y equals 0. What are the values of x when y is equal 0? So these are basically x-intercepts. Okay, so the value that the graph intercepts on the x-axis. So this is going to be your x-axis, this is going to be your f of x, or the y-axis. So basically, let me point all the points. So this point, this point, this point, this point, and this point. So they are all 5 together. So those are actually the zeros. So I have all 5 together for this case. Okay, so it's basically the x-intercept. Okay, for this case, I have two local or relative maxima. So what are my local or relative maxima? So it's going to be this 2 point over here. So this over here, negative 3, 2, and also 2, 1. So they are the, let me put over here. So 3, 2 and 2, 1, they are both local maxima, okay? Because they are turning point, and it's actually a maximum turning points. And as for negative 1, 3 and 4, 1, so negative 1, 3 and 4, 1, so they are going to be the, so let me correct it, 4, negative 1, so those are going to be the local minima. Okay, but there's one thing that I would like to remind about this graph over here. So for this case, our global maximum and the global minimum, it will be positive infinity and negative infinity, because here the graph doesn't stop just until here being the highest. So we have an arrow right here, so meaning that this is going to point towards infinity, an arrow over here as well, so meaning that our graph is going to point towards negative infinity. So what is going to be our global maximum? Our global maximum, the highest point is going to be at infinity. Our global minimum is going to be at negative infinity. So that is the global minimum and maximum. So the turning points are local maxima or minimum. The global is going to be the highest, or for cases like this, it could be positive infinity and negative infinity. So let's have a look at another example here. Okay, so here, so it's being told right here. So the first statement, B, C, D, and E. So this, and this. So they are called as the turning points. Okay, so turning points could either be maximum points, or it could also be minimum points. So it doesn't matter. Both of them are called as being turning points. So let me highlight this with turning points. Okay, so B and D, so these two, they are like high points. Okay, so they are called as the local relative maxima. And on the other hand, so C and E, so they are minimum points. They are local maximum, so they are called as local or relative minima. So it's minimum points. Okay, so the minimum value, so when I have a look at this function right here, so where is going to be between these two, where is going to be the lowest? So the lowest is going to be at negative of 12. So this is actually not a turning point, but this is actually the lowest point here. This is going to be my lowest point. So therefore A is going to be the global minimum, because it is the most, it's not the most lowest, that's bad English, that is the lowest point for the y-axis. And of course, where is going to be the highest point? So the highest point is going to be at B. So therefore for this case, so B is going to be the global maximum. That is where the highest point of y lies, and A is going to be the global minimum. Okay, and as for the zeros, so there are 4 zeros altogether in this function. So where are the zeros? So what the y-intercept, 1, 2, 3, 4, and 5. Okay, so there are actually not 4, but there are actually 5 zeros in here. So let me correct that. So there are 5 zeros in the function, and 2 of them are labeled as being A and B. So this is my A and this is my B. Okay, they are 4 together. 1, 2, 3, 4, and 5. Sorry, it's 5 altogether. Okay, so those are difference between, I hope now you have a clear idea between the local and the global. So local, just the turning points. Okay, so those are referring to local. It could be like more than 1 point, but the global, there's only 1 point. It is the Okay, next we're going to have a look at average rate of change of a function. So basically for a certain function, so when we say average of change, basically we're just referring to the slope value. And we know that slope, it could be positive and it could be negative as well. So if the average rate of change is positive, or slope is a positive value, so meaning that your function is actually increasing. Okay, so when slope, positive slope, so your graph must be increasing, going up. And when you have a negative of slope or negative average of rate of change, so meaning that your function is going down at that certain interval or value of x. Okay, so in terms of the formula, so the slope is going to be the change in y, which we usually denote by delta of y. Delta means change, over delta of x, which is going to be the change in x. The formula is going to be, if I have two coordinates, which is going to be x1, x2, sorry, this is not x1, x2, it's x1, y1 and x2, y2. How do we calculate the slope? The formula is going to be y2 minus y1 over x1, x2 minus x1. Or you can also use y1 minus y2 over x1 minus x2. Doesn't matter which one is you use. Both of them are going to give you exactly the same answer. The only important point is that the order must be the same. So if you start with y2 at the top, at the bottom also start with x2. If you have y1 at the top, at the bottom, it's also going to be x1 minus x2. It has to be the same. Okay, this is going to be an example. When you have a linear function right here, the slope is going to be constant. So no matter what point you choose for the interval, for example here, I have 2 points for the top one. So I choose two coordinates of 1, 3 and also 2, 5. So the slope is actually the same as what I have down here. So which is going to be at -1, -1. And also -2, -3. So the slope are the same because it's a linear function. So everywhere along the lines, so the slope is constant. The slope is going to be the same value. But when you have a quadratic function, so depending on where do you pick the function, so here it's going to be from 1 until 4. Okay, so this is going to give you an average rate of change of 3. And down here, when you pick the value between interval between 0 and 1, you get that the average rate of change is going to be 1 because the function is not the same throughout the interval. So the shape changes throughout the interval. It's not the same. So the slope is not constant for the case of a quadratic function. But I think like the only slope that is going to be constant only will be for linear, but for the rest it will change according to the interval. Okay, so here I have a function g of x. I'm going to find the average rate of change over the interval from 1 until 4. So where is going to be the interval? So it's going to be from here, 1 until 4. So first what I'm going to do is, I'm going to identify the coordinates because we have coordinates right here. The first point, my coordinates is given by 1, 1, 1, 1. So the second point, it's given by a value of 4, 2. Okay, so now if I want to find what is going to be the average rate of change, so I put over here, so average rate of change when I apply the formula, so that is going to equal, so this is, for example, is going to be my x1 y1, this is going to be my x2 y2, and I'm going to use the formula y2 minus y1 over x2 minus x1. So I will have a 2 minus 1, so that is going to be for the y coordinates, which is going to be this 2, over, because I start with y2 at the bottom, I also have to start with x2, that is going to be 4 minus 1, and then I'm going to end up with 2 minus 1, which is going to be a 1, 4 minus 1, that is going to equal a 3, and you can check, you can see how this graph is actually going up, it's increasing, and I got a positive value for the average rate, so that is correct. So that is going to be our average rate of change. So on the interval from 1 to 4, and this interval actually referred to the x-axis, right? So my average rate of change is going to equal 1/3, 1 over 3. Okay, so this is going to be the exercise. Why don't you try this for yourself? Okay, so basically for this one, the coordinate is already given, and try to figure out what is going to be the average rate of change for this case. And this x, f of x, basically coordinate 0 and 1 means that the coordinate is going to be 0, 1. So that's a hint for you to proceed with the exercise. Yep, that is going to be another exercise as well. Okay, but before that, there's something that I would like to point out. For example, if you are given a function, for example like this, ht, and you would like to know what is going to be the coordinate. So the coordinate for this case, it's going to be, if we were supposed to sketch this, so variable on this side is going to be t, so t is going to be the horizontal axis, and h of t is on the left hand side, so it's going to be the vertical axis that is going to be h of t. So when you find the coordinate, for example, so if you have t equals 0, so the coordinate is going to be like this, so it's going to be t h of t. So if you wanted the case when t is equal 0, when you wanted to find what is going to be the h of t value, all you have to do is substitute right here, h of 0. So everywhere there is t in the function, so all you have to do is replace that by 0. So this is going to be -16, so 0 square plus 50 multiplied by 0, and then plus a 3. And for this case, what is going to be the value then? So it's going to be a value of 3. So that is going to be the first coordinate that you have, which is going to be 0, 3. And when you want to know when t is equal to, so you're going to do the same then. You're going to substitute all the t's by the value of 2, and that you will get the second coordinate and so on. Okay, so try this exercise, And if you get lost some Right, so now that you already have the idea like how do we sketch graph, next we're going to have a look at techniques of graphing.